This video covers the computational thinking skills that CIE put into section 9.1. It's a very short video. The next one will be on 9.2, which are algorithms. So the first one is abstraction. This is about focusing on the essential details and hiding what you don't need. So a definition would be the process of removing unnecessary detail from a problem or system, so that only the characteristics needed for a particular purpose remain, and this produces an abstract model. So why do we need abstraction? Well, real-world systems and problems are very complex sometimes, and they're too complex to represent or reason about fully in a computer system. So the abstraction reduces complexity so that the problem becomes more manageable. And it allows the programmer to focus on what's relevant to the task and not waste their time doing things that aren't. It produces a model that's easier to design, build, and test. So on the right here we have an example. It's a book system where we have lots of details about books, about where the books are. We've got things like the title and ISBN, but we've also got things like shelf color. So abstraction would just mean removing the things that we don't need, we're not particularly interested in for this particular purpose. So for example, if we're talking about borrowing books and that's what we're interested in, then we don't need things like shelf color, font, and the room temperature. We only need the essential pieces of information. So if you were asked to abstract a particular scenario, you look for things that are essential to the purpose given and remove those things that aren't essential for that purpose. Then we have decomposition. And decomposition is about breaking complex problems down. So a definition might be splitting a complex problem into a set of smaller sub-problems, each of which is easier to understand, solve, and test than the problem as a whole. Sometimes referred to as a top-down design. So you start with the big complex problem and you break it down and then break it down further and further and further until you get to the point where the modules or the smaller parts are simple to solve directly, simple enough. And subproblems that are small enough can be coded as procedures or functions. So this leads to a modular implementation of the system. Sometimes we use what's called structure diagrams or hierarchy diagrams to show how a problem has been decomposed. At the top you have the whole problem, and then you break it down into your initial set of subparts or subproblems. And then sometimes you might find that your subproblems are themselves too complex, so you decompose it further, break it down into even smaller blocks, and that's how you'd show it. So you go from top down, and then these ones might be small enough to actually implement with functions and procedures. And that's all there is for this section of the spec. As I said, it's very short, and next time we'll look at algorithms.